Okay, in the last few videos, we've talked about functions and their inverses and how to algebraically find them. And we've talked about exponential functions and some of their properties. Now we're going to kind of combine the two things. Essentially, the idea is, if we know what an exponential function is, and say, just really quickly, the graph of an exponential looks something like that. We know that graph is 1 to 1. And then we know from what we learned about inverses, if the function is 1 to 1, then it has an inverse. And if exponential functions are important, and they are, we said, then it would seem logical that their inverses should also be important. And as it turns out, they are. And the inverses of exponential functions are called logarithmic functions, or logarithms. Logarithmic functions. And we're going to kind of go through the properties of these things to make sure we understand them. But as far as the definition goes, log base a of x equals y means a to the y equals x. Again, using our understanding of exponentials, when we wrote exponentials before, we had a to the x equals y. And we said to find the inverse of the function, you flip the x and the y around. So then you would get a to the y equals x, which is what a logarithm is. But instead of writing it this way, we generally write it this way. Log base a of x equals y. Keep in mind here when we had an exponential, a was the base. Here it's log base a of x equals y. As far as how these things work, suppose we have something like log base 2 of 8. Once you kind of understand what a logarithm is, these can be relatively simple to solve, a lot of the ones we're going to look at. But if you're unsure, at least to get an idea, log base 2 of 8, suppose it's equal to y. Now use the definition. Log base 2 of 8 equals y means 2, the base, to the y equals 8. Now we say, what power do I raise 2 to get 8? 3, because 2 cubed is 8. So then, y is equal to 3, so log base 2 of 8 equals 3. And essentially the idea is, for logarithms, you're looking for the power that you raise the base to get that argument right there. So if we have log base 3 of 9, what power do I raise 3 to get 9? 2, because 3 squared is 9. If we're still unsure, we can use a definition. Log base 3 of 9 equals y means 3 to the y equals 9. And now it's clear 3 squared equals 9, so y has to be 2. Good. Now that we have the definition, we can kind of work with these. There are properties a lot like there are with exponentials. So suppose we have log base 4 of 4. So then by definition, what would that be? What power do you raise 4 to get 4? Well, that should be power 1. If I want to check it, 4 log base 4 of 4 equals y means 4 to the y equals 4. And then sure, y has to be 1 because 4 to the 1 equals 4. How about if I have log base 3 of, let's see, 3 cubed. Well, let's see, what would that be? If I use my definition, log base 3 of 3 cubed equals y means 3 to the y equals 3 cubed. Now just make sure not to get confused here. That means 3 to the y equals 3 cubed, which is 27. And then what power do you raise 3 to get 27? 3. Because 3 cubed equals 27. So y has to equal 3. So log base 3 of 3 cubed equals 3. It's a whole lot of 3's there. We could play around with these a little bit more, but for right now, maybe we'll just do one for fun. Suppose I have 2 raised to log base 2 of 8. Now I'm combining both of the things I was looking at, logs and exponentials. The question is, what would that be? If you kind of say this in layman's terms, 2 raised to the log base 2 of 8, by definition, log base 2 of 8 is the number you raise 2 to get 8. So, if you take the number 2 and you raise it to the number you're supposed to raise it to get 8, what should you get? If that's still a little bit confusing, work it out. Start with the power, right here. By definition, we already did this, log base 2 of 8 equals 3, because 2 cubed equals 8. So then 2 to the log base 2 of 8 equals 2 to the 3, which is 8. And now again, kind of what I was saying before. Log base 2 of 8 is the number you're supposed to raise 2 to get 8. So if you take the number 2 and you raise it to the number you're supposed to raise it to get 8, what do you get? 8. If you think about it, it actually makes sense. So if we understand the trick, suppose we have 5 raised to the log base 5 of 37. So now, without using the definition or anything like that, log base 5 of 37 is the number you're supposed to raise 5 to get 37, which is some weird number. So if I take the number 5 and I raise it to the number I'm supposed to raise it to get 37, I'll get 37. This is just kind of a fun little mathy type trick that we like to do in math, so be aware of that. Plenty of time. Okay. But you'll notice, and I've deliberately done this as we're doing these problems, I can use any base I want. We've used base 3, base 2, base 5, pretty much anything we want. As far as it goes, though, there are some bases that we use more than most. First off, we have what's called the common log, which is log base 10. Essentially, it's the base we counted, 10 fingers, 10 toes, 10 digits. So the common log is log base 10. If you look on your calculator won't say log base 10, it'll just say log x. And essentially, that is the same as log base 10 of x, or log base 10 of some number. So we could write something like log base 10 of 100. What number do I raise 10 to get 100? 2, because 10 squared is 100. But generally speaking, this is called the common log. It's the base we're all used to. So a lot of times we'll just say log 100 equals 2. We drop the base because it's the base we understand, base 10. So just be aware of that. Also be aware, as far as the calculator goes, your calculator can't solve problems in base 3 or base 5 or base 7 or base anything other than base 10, which is the common log that we just looked at, and one other base. And that's base E, for the letter exponential function E. Essentially, the idea is, we talked about exponential functions and they were important. We said e to the x was like the most important exponential function. Exponential functions have inverses. So if this is the most important exponential function and it has an inverse, then it would stand to reason that its inverse is also really, really important. And it is. It's called the natural log. The way we write it is log base e of x, or log base e of any number, but generally speaking we shortcut that to ln of x. Again, if you're looking at your calculator can calculate things in base 10, the common log, and in base e. It'll just write ln of x. It should be right near the log button, probably directly above it or below it, or it's like the second command there, based on what calculator you're using. But essentially, we write it like this. Again, if I write it in this shorthand, which is how we're going to write it, you don't write the base here, you just say ln of x, because it's understood that's log base e of x. It's just a shorthand notation. So, suppose we have ln of e. What's that equal to? Well, if I use the definition, ln of e is log base e of e, and then we say, what number do I raise e to get e? We already did this with the other, log base 5 of 5, log base 2 of 2. That's just 1. So, as far as it goes, we are going to spend essentially the rest of the semester working on these exponentials and working on these logs. For right now, you need to know what a logarithmic function is. You need to know how to calculate them, like we did here. You need to know what the common log is, log base 10, and how to find it on your calculator. You need to know what the natural log is, log base e, and how to find it on your calculator. And then ultimately we want to solve problems because, be aware, if I have log base 5 of 25, what number do I raise 5 to get 25? Oh, that's 2. 5 squared is 25, and that's easy. What's log base 5 of 30? What number do I raise 5 to get 30? That one's actually kind of a problem. It's just some bizarre decimal irrational number. You can't calculate it by hand. You're going to need to use your calculator or some algebraic tricks to solve it. And that's what we're going to spend the next few videos, lectures, labs, classes working on. The different algebraic tricks necessary to actually solve a problem like that.